what do we got? 4.4, number 6E. All right, so your setup looks like this. This guy was 25 kilograms. This guy is 10 kilograms. We know this angle here, despite the fact that my drawing doesn't look like it, that this angle here is 20 degrees. All right, so let's identify our forces. So the forces that are going to act on this thing are, you're going to have the force of gravity on the 10 kilogram thing, which is just 98 newtons. I'm not going to put in any negatives yet. Okay. You've got your parallel component of gravity, which, if you figure it out, turns out to be 83.8 newtons. That's going to be in my way. Darn it. Your FG perpendicular ends up being 230.2 newtons. There's a normal force, which is equal to your FG perpendicular. I'm going to cheat and do some shorthand there. All right. So that's our starting setup, just with no friction, no force of Roy or anything. So is everybody okay up to there? Good. Okay, so if you read through part E, it says, suppose Roy pushes the 10 kilogram box of sandpaper up with a force of 80 newtons. So at this point, it's probably worth our while to take a second and consider signs. Okay? So with no external forces, which way is this system going to move, you guys? To the right or to the left? Wouldn't it move to the right because this gravity force is sort of winning over the 83.8 over here, right? So let's arbitrarily, let's call this way positive and this way negative. Follow? Mm-hmm. Yep.
There's no friction.
I'm about to put friction in. I haven't gotten there yet. All right, so everybody get up to there. All right, now, it tells us in the problem that Roy is going to push this 10 kilogram box upwards with 80 newtons. All right, now where you put that force doesn't really matter. What's important is that it's contributing to motion in a negative direction. Does that make sense? Right? Because he's sort of pushing the system up this way, right? So whether you put the force of Roy here or over here doesn't really matter. Okay? I usually like to put it over here just because it kind of helps me process. But I don't know. Anybody care where we put it? You guys see what I'm saying? Mm-hmm. All right, so I think I'm going to do that if you guys don't, if that's not going to weird anybody out. So over here, here's our force of Roy. You know what? That's misleading. I don't want to do that. Let's do it the original way. All right, so here we go. Force of Roy. 80 newtons. Positive or negative, you guys? Negative. Good? All right, so right now I've got 160 newtons pushing it in a negative direction, but only about 100 newtons in a positive direction, right? All right, we had previously figured out our static friction maximum, and it's only 23 newtons. So can static friction prevent the motion?
No.
No. So we got to go to our kinetic friction, which is 18.4 newtons. Which way should that kinetic friction go, you guys? Positive or negative?
Positive.
Positive, right? Because it's going to resist the motion in a negative direction. Good? Any problems? Molly, you good?
Yeah, I just drew the friction going the wrong way.
Gotcha. Do you understand why it's got to go that way now? All right. And this is a tough problem, you guys. I tried to make this review tough because I figured you'd be better having the test easier than the review than the other way around, which I think it is. All right. So we good? All right, so let's now find our net force on the system. So the net force on the system is going to be, well, let's see, we got to add all of these up. So we've got 98 newtons from gravity, minus 80 newtons from Roy, plus 18.4 newtons from friction. minus 83.8 newtons from the parallel component of gravity. So if you add all that garbage up, it gives you a net force on the system of negative 47.4 newtons. Is that right?
Yeah.
Oh, right. Gotcha. Yeah, that makes sense. Cool. Yeah, Elizabeth?
Did you know that the friction was going that way because the other forces was larger?
Correct. Yeah, so the other forces are going to win, so it's going to move in what we have labeled as a negative direction. Are you good or no? Everybody good? Okay. The big thing that I want to make sure you guys understand here is how Roy's force affects the system. That it's a force in what we've called a negative direction, so you need to make sure you incorporate it that way. All right, so we all good up to here? All right, so now we can find the acceleration of the system just by doing net force over mass, and you end up getting negative 1.35 meters per second squared. Cool?
And then you do both of the masses combined for that one? Right?
Correct. Yep. Yes, that was
Okay.
total mass. Good. I'm sorry I didn't write that down. All right, everybody good? All right, so real quick then, let's find the tension in the rope. So to find the tension in the rope, you can look at either the 25 kilogram thing or the 10 kilogram thing. If you do the 10 kilogram thing, don't forget to include Roy's force. If you do the 25 kilogram thing, don't forget to include friction. Okay? And your tension force is going to act, in both cases, up, right? Carson?
We do it, I did the 10 kilogram, 10.
Okay, let's do it. That's just about to ask. Okay, so here we go. 10 kilogram thing. I know the bell's about to ring. I'm going to finish it either way. So here we go. Our force of gravity is 98 newtons. Let's make it negative now. Force of Roy, 80 newtons.
Yep.
What's my acceleration? Be careful.
Okay. So it was 1.25 but inside.
I don't know if you just heard what Carson just said. He said it's 1.35, but the sign would be, and this is what we need to decide on. Point for me. Which way is that thing going to move in, you guys? It's going to go up, isn't it? It's accelerating up because the other forces were going to win. So this is a positive acceleration. Even though for the system it was negative, right? Good? Carson, you good? Everybody good?
Yeah.
So now we can find the net force by doing mass times acceleration. That's going to give us 13.5 newtons. Positive. The mass I used there was the 10 kilograms. Good, Carson?
Yep.
And now we can find our tension, right? So net force is force of gravity plus force of Roy plus force of tension. So you get 13.5 equals negative 98 plus 80 plus the force of tension. And it ends up giving you, whatever, 31.5 newtons.
Yep.
Good? All right, cool. So what I'm going to try to do, you guys, so I just recorded that. I don't know if did I tell you guys this, that I was trying to record when I do